Greetings to all and welcome to the next session on programming in Python course. In this particular session, we are going to deal about an wonderful Python data structure called as sets, right? So what is set, right? If you have a set of items, I usually say set of items, set of elements, set of data, everything, set. So set is actually a common word. Now we have already seen some data structure like list, tuple, and strings, etc. So what is the difference that is going to come here in sets? So that's what we are going to see in the introductory part. We know that list is actually a data structure where I can have a sequence of data items separated by commas, and list is a mutable data structure. That is, I can change the data items that is present in the list. A sequence. Tuple is also a sequence of data items. I can store any data values, any data type separated by commas. And the difference between list and tuple is in tuple I cannot not make it mutable. That is, it is immutable data structure. That is, if you fix a particular data item in an index, its value cannot be changed. So it is an immutable data structure. Now again we say another sequence is available. So that is actually called as sets. What is going to be the difference here? Yes, it is going to be exactly different. We will go step by step what is actually the difference in sets. So we'll go with the very basic. We usually represent list in square brackets. Then we'll go to parentheses for tuples. Now for sets, I'm going to give a new kind of brace called as curly brace. So this is actually you'll call it as flower braces or curly braces. This is actually for sets. So sets is also a sequence of data items, can store any data type of items. So here the main difference which is going to be when comparing to list and the tuple is the values cannot be duplicated. Here if I have 1 comma 1 comma 1 in list, yes, it is correct. In tuple, can I have 1 comma 1 comma 1? Yes, it is correct. But when I'm going for set, you cannot have duplicate values. You can have only unique values. So if I say 1 comma 1 comma 1, it is not separate things. You should not say like that. It will automatically delete the duplicate ones and it will have only a single value. So here, what is the major thing to go into this particular data structure is this particular data structure will automatically remove duplicates, and at the same time, it is very good for searching a particular data item. So it is having a very good searching capacity. The complexity of searching is very less in this particular sequential data structure called sets. For example, I have a set A is equal to, I'm giving a set of items separated by commas inside flower brackets. I have curly braces. 1, 2, 3, 4, 5. If you see here, all the data items are different and they are actually unique. So if I am having any duplicate values here, automatically they will be removed off. And I'm having here B is equal to set of. Why I'm saying set of? We all know that if I want to convert a data structure to another data structure, I will call the data structure to which I need to convert. For example, if I want to convert a list to a tuple, I just say tuple of. If I want to convert a tuple to a list, then I say list of. Similarly, I'm having here a list, right? Here the list is having 3 items, king, queen, and soldier. And I need to convert this list. Why I'm calling this as a list? It has been enclosed inside square brackets, and I say set of this particular list. Now what will happen? This particular sequential list will be converted into a sequential set, right? This is actually the conversion that is what taking place, common to other data structures also. Now I say here print 1 in A, whether 1 is present in A or not. That is the membership operator. Print 1 in A. Yes, 1 is present in A, right? Yes, true. So I get here true. Similarly, I am saying print whether king in B. Yes, king is present in B. I am getting a true value. So this is how you actually use the membership operators in sets. Whether these are the only differences, that is Sets is going to maintain only unique values. That is what making it more prominent. No, as I already said, in sets we have an beautiful feature called as searching. Right here, searching a particular data item becomes very fast. We will see how it is. Here in sets differ from list in several ways, but share several list operations such as lenof. We know that lenof is used to find number of elements in a particular sequence. So lenof is available in sets also. The important difference here is sets will not have ordering in their index. The position of the element is not constant, and each time the position varies arbitrarily. So what happens? There is some internal changes happening in the positions to make the searching process efficient. So there is an operation which is done internally by the Python compiler. So when you search for a particular element, such data structure assures you that you will get a faster response than any other data structure. So to make searching efficient, they have made an unordered data structure sequence that is actually called as sets. Since it is being unordered, you cannot access the element by using the index. Why I cannot access? If I say A is equal to 1, 2, 3, 4, 5. For example, I'm saying a set A is equal to, assume that I'm saying 1, 2 and 3. Say for example, we have a 3 element set. And I'm enclosing it within curly braces or flower brackets. So it is actually a set. Now, if I need to access a particular element, if it is a list or tuple, I can say A of 0, which is 1, A of 1, which is 2, and A of 2, which is 3. I can do like that. Negative indexing also I can do. But when I go for sets, here the elements are not perfectly ordered. They are unordered. Why it is becoming unordered? Say for example, I maintain a set A. Since we already have A, I go for A1 is equal to, and another set. I'm naming this set, the elements in the set is going to be 1 comma 2 comma, again I say 1 comma 1. So what will happen is my Python compiler will convert this particular sequence into a set which is not having any duplicate data items. So if you print A1, I will get only 1 comma 2, and I will not get these repeated values. These repeated values will not be obtained when I go for printing A1. Why? Because they are duplicated. The elements are already present, and if you try to add a new element into a set which is already present, it will not include the particular element. Now, for example, assume that I'm having 1 comma 2 comma 1 comma 1 comma another element 3 is also present. Assume that you are having an element 3. So what will actually happen? If I delete this initially during the entry process, I know that 3 is in the index, say 4. 3 is in the index 4. Now set will make some operations to remove the duplicate data items. Now 3 automatically comes to the second index. So this indexing operations will give some trouble to the user when the process is being done for deleting the duplicate items. So what ultimately will happen? The user doesn't know the exact position of data items. So what set says that there is no index for the data items included in the particular sequence. Then you can ask one question. Then how can I access the element in the set? You cannot access using index, but you can access using the membership operator. You just use in and then access it. But the order in which the element are displayed will be different. It will not be the same order. The order in which the elements are displayed will be different at different instance. Next, coming to some methods which are available in set. There is a method called as remove, which can remove the specific element. For example, in the above example, A is equal to 1 comma 2 comma 3. If I say A dot remove of 3, it means that I need to remove the data item 3. Similarly, coming for pop, which is most important to understand here. Why? We already saw the pop method available in list. In tuple, pop is not available. Why? Because tuples are immutable and we cannot make pop available in tuple. But in list, I have the pop method, which will by default removes the last element. and I can also specify the index for deleting the particular element. But here, why set is also having a pop method? Here index itself is not there, when then how pop will work? Yes, still pop will work in sets. What it will do? Here you need not specify the index, but just to say a dot pop of, where a is a set of elements. In this case, if you say pop off, you will not get the last element deleted. You will get an arbitrary element that is being deleted. Arbitrarily, any one element will be deleted. So you can think, then what is the use case? Yes, there cannot be much use case here because an arbitrary element is coming. But if you want to take a random element out from your set, then you can use pop. That's the thing. That's what you can actually do. You can also append an element, but here appending is not there. Instead, you can use a method called as add. This add method will add a new element into a set. That's what the element and the method append will do for list. Here the method called as add, which is going to do for sets. Sets can also be related to mathematical operations. You know, right, the set theory. We have union operation, intersection operation, difference operation, symmetric difference operation, and so on. Many other set operations are available. Everything is possible in the set data structure also. We have predefined methods and operators available for doing these things in Python. So what ultimately it does is, when a particular concept is more famous in mathematics for a particular application, Python is giving a separate data structure to handle those things. So making the entire process easy, right? That's what the ultimate goal. So if you want to do something with set theory, you have a separate data structure for doing it. So that's what an ultimate aim of Python, to make every process easy. So how? Right now we are going to say taking two sets, say for A is equal to A, B, C, D, E, F, G, H. And I'm having another set B, X, C, A, Y, Z. Now I'm saying A, pipe B. This particular operator are actually called as pipe operator, also called as union operator in Python. This is actually the union operator. So if I say union, what will happen? I will combine the elements of A and B and put it inside a particular new set. So A and B will be combined now. So I will get A, B, C, D, E, F, G, H, comma X, Y, Z. Why? Already the elements C and A are present in the set A. So these elements are duplicate values which should not be included in the resultant set. Have you understood the importance of set? If it is a normal list, then I combine both the things by using the concatenation plus operator. It will include all the elements. But when coming to set, it is actually avoiding the duplicate values, which has enormous applications in several different programming scenarios to automatically delete duplicate values. So if I want to delete the repeated occurrence of a particular data item from my sequence, what I will do, just I will call the set. I'll call the set method. I'll convert my entire sequence into set. Immediately I will get a result. How good it is, right? Now going for intersection, how to find the intersection between two sets. So intersection operator is going to be ampersand operator, and so if I say A ampersand B, I'll get an intersection where for this particular two sets, the matching common items are A and C. Next comes with difference operator. So what is difference? Difference means A minus B is actually the difference. Difference between A and B is the elements in A which are not in B. The elements in A which are not in B. That's what the result is. A minus B represent elements in A which are not in B. So what are the elements in A which are in B? A and C. So if A and C is there, so what I have to take? A and C should not be included because they are in B. So elements in A which are not in B are B, D, E, F, G, H. I will remove A and C because they are in B. So I should not take them. Next comes symmetric difference operator. So what is symmetric difference operator? Symmetric difference operator is going to have an operator as cap. So we denote this particular symbol as cap. You will use the power operator, right? Here A cap B is used to represent a symmetric difference. So what is the symmetric difference? Very simple. Here A minus B says that all the elements in A which are not in B. That's what the A minus B says. What is symmetric difference is A minus B union B minus A. That's what is symmetric difference. Elements in A which are not in B. That is on one side. Elements in B which are not in A. That is on another side. You combine both union, then you'll get a symmetric difference. That is A, B, C, D, E, F, G, H in A. And I know that A and C are the elements present in my B also. So I remove those two elements. Those two elements are not needed for me because they are common to both the sets, and I'll combine the rest B, D, E, F, G, H, X, Y, Z. That's what actually called a symmetric difference. That is A minus B union B minus A is actually called as symmetric difference, represented by the operator cap. Yes. So these are some of the mathematical operations which are actually present in Python set data structure also. There are actually equivalent methods are also available. For example, A union B is equivalent to A dot union B. So the result will be stored in A itself. A ampersand B, that is intersection, can also be represented as A dot intersection of B, and the result will be stored in A. A minus B, this is actually capital B. A minus B is equivalent to A dot difference of B. Likewise, we have the equivalent methods available for doing the similar operator functions of sets. What else we have in sets is, we also have an equivalency, that is if whether set 1 is equivalent to set 2, that is we represent using double equal. Whether set 1 is not equal to set 2, exclamatory mark equal to. Set 1 is the subset of set 2. So subset operation is most important. So what is subset? For example, if I have a set 1, 2, 3, 4. If I say there is a set 1, 2, 3, 4, which is actually represented as S1. If I say this is going to be my S1, and I say another set S2, which is going to be 2, 3. I'm having another set, say set 2 or S2, which is going to have the data items 2, 3. Now what you will say, set 2 is less than or equal to S1. S2 is less than or equal to S1. Why? Because it is a subset of S1. The items in S1 is actually subsetted in S2. For example, 1 is the subset of S1, 2 is a subset of S1, 3, 4, everything are subsets. So this 2, 3 is also a subset of S1, right? Next, S1 less than S2. What is S1 less than S2? It is a proper subset of S2. Proper subset in the sense it includes one or some of the elements of S2, not all the elements. That is actually the proper subset. Similarly, if S2 is going to be the subset of S1, then I can say S1 is the superset of S2. Superset in the sense it is actually containing the elements of the smaller sets. S2 is smaller and S1 is larger superset. It includes the elements of S2. All the elements of S2 are present in S1. Then what I say, it is a proper subset of S2. So that's what is stated here with subset and superset. So this is with respect to set operations, and to summarize everything, we will explain what are the set data, what are the things available in set data structure. Set data structure is also a sequence of data items which can store any data type separated by commas, usually represented by enclosing inside flower brackets or curly braces. In sets, we say two important difference comparing to other sequential data structures including list and tuple. The main differences are sets will not include duplicate data items. Second one, set will not follow any ordering in their index. Why? They want to make faster searching, so they make indexing as negligible. There is no indexing available in sets, unordered items. So set also supports all the mathematical set theory operations, including union, intersection, difference, symmetric difference, everything. All the set operations of mathematics is available here as both operators and methods. We also use subset, superset, equivalency, and so on. Right? Extraordinary amount of operations are also available in sets. Thank you.